So again, one more time. Hi, my kids. So this is the second session for your physics of 9th standard, and we will start with the subject called as motion. So yesterday we discussed about these SI units. In that, one doubt was there. I wrote the SI unit of mass as kg, and after that I changed it into gram. But actually it is kg, kilogram. Okay, it's not in gram. So SI unit of length in meter, SI unit of time is second, SI unit of temperature is Kelvin, not degree Celsius. SI unit of mass is kilogram, and force is Newton. Understand? So whenever one more time I am telling anyway. Whenever numericals are there in physics, if that values are given in anything rather than SI unit, you must convert that into SI unit. For example, in the case of length, if it is given in kilometer, you must convert it into meter. In the case of time, if it is given in minute, you must convert it into second. If it is given in hour, you must convert it into second. So, in the case of temperature, if it is given in degree Celsius, you must convert it into Kelvin. And if it is in the case of mass, if it is given in grams, you must convert it back into kilogram. So that is the way of doing numericals. Otherwise, it is a simple thing. Okay, conversion is a simple thing. You will get only half mark for that. But if you don't convert it, your answer will be wrong. Again, 1 mark will go there. Mostly numericals comes 2 mark question and 3 mark question. Stand easy. At least like 6 or 8 marks for every paper. There is numericals. And these students, what they already have in their mind that these numericals of physics are very tough. Actually, it is not very tough. If you know the equations, if you know this conversion method, and if you know basic mathematics, you will get the marks. That's it. So let's start with the first one, which is called as motion. Before moving to this motion, we need to understand some things. Okay, some things you must understand. So that is also basic of this physics. Okay, that is not in chapter, but this you must understand. Want to go with scalar and vector. Scalar and vector. Oh my God! Even the college students, even the engineering students, they are boiling their head. They are scratching their head by hearing these vector quantity, scalar quantity. Oh my God! What is that? Displacement, distance. What all things are that? So it is nothing. In simple definition, we can say scalar means only one thing is there. Okay, scalar, only one thing is there in scalar, and that one thing is, you have one thing here, magnitude, and you have another thing here, direction. Anyway, direction is very familiar word, isn't it? You already know the meaning of direction. Okay, I am going to that direction. Mostly our earth is divided into east, west, north and south, isn't it? So you know what is direction. If I am going to market, in this case, I am going to market. I am going from this position to the market. So that is my direction. Alright or not? If the school is there, so I am going from here to that direction. That is the direction of mine. So you know what is this direction? Understand? What is this magnitude? Magnitude, actually it is a measure of value. Understand? It's a measure. For example, length we can measure. I am going to that direction towards the market. And how many kilometers from this point to the market? That is this magnitude. Understand? Magnitude, we can measure it. For example, 2 kilometers is the magnitude. So in the case of scalar quantities are those quantities. Some of the quantities have written it here. Okay, some of these quantities I have written like length. You know what is length? From here to there, that is length. Speed, the speed of a bike, speed of a car, speed of a bird. Understand? Speed of running cheetah. Cheetah is the animal which has the maximum speed on land. Understand? Animal. Temperature, how much hot it is, how much cold it is. Mass, the weight of a particular thing. Force we want to exert. Okay, the force we have. I am holding this pen in my hand because I am applying some force. Otherwise, the pen will fall down, isn't it? Weight. And one more thing, this mass and weight. You will change the pen here. This mass, both seems to be same. Am I right or not? Mass means how much kg I am. But what is weight? Weight is also same. What is your weight? You are 75 kilograms, you are 50 kilograms. So what is the difference between weight and mass? Can anybody tell that? It's nothing. Mass is the original weight. Understand? I am now 75 kg, but my real mass is not 75 kg. Understand? Why I am feeling 75 kg inside me? Because it includes the gravitational pull also. Understood? The gravitational pull. Mass means actually we need to. The real weight is called as mass. But what weight we are using? It includes gravitational pull also. So the effect of gravity is in the weight. Next one is acceleration. Accelerator. You heard about accelerator in your bike or in your car. If we just step on that accelerator, your car or bike will move with speed. That is also a value. Displacement is also different values. So scalar quantity and vector quantity. So these are different types of quantities. In scalar quantity, you know that only magnitude is calculated. Understand? Only magnitude. There is no relation between direction. For example, we can say length. This is scalar or vector. I will say it is scalar quantity. Yes. Because, for example, take what? Okay, see, this pen is a good example for that. I have this sketch pen in my hand. Mostly it will be like 10 centimeters in length. I don't know. In which direction I am measuring it, it will be same as 10 centimeter. I am 165 centimeter tall. If I lay down, my direction is like this now. Then also measure, it will be 165. If I am on my head, I am standing on my head, then also if you measure me, my total length will be a constant, isn't it? There is no difference. This direction does not have any impact on length. That's why it is called as scalar quantity. Understand? Only one thing is there, magnitude. Direction is independent. Direction is no need for this scalar, length. Length is length. Anyway, that's the thing. Understand? For example, a length of a bus is 20 meters. In whatever direction it is going, it will be 20 meters, isn't it? There is no difference in that. So, length is a scalar quantity. Speed. For example, I throw a stone from this place to that place. Understand? That stone is flying with a speed of 10 kilometers per second. In whatever direction I will throw, the speed will be same. Any difference? Any difference will be there. For example, your bike's maximum speed is 100 kilometers per hour. Understand? If you are traveling in east direction, then also it is 100 kilometers per hour. If you are traveling in south direction, then also it will be 100 kilometers per hour. So we can say speed is also what? Speed is also a scalar quantity. Understanding? It's a simple thing because there is no direction does not changes anything regarding scalar quantity. That's why it is called as scalar quantity. So next one is temperature. Temperature is our body temperature. My body temperature is what? 98 degree Fahrenheit. Or just imagine 37 degree Celsius. So in wherever direction I move, then also the temperature will be same. Understand? I am standing in this direction. My body temperature is 37 degrees Celsius. I changed into this direction. Any change will happen in my temperature? No. If I move here, any change? No. So temperature also nothing to do with this direction. It is also what? Scalar. Mass means the real weight of a particular thing. If something's weight is 10 kg in any direction, if for example the same pen, this is like 50 grams. If I weight it like this, it will come 50 gram. If I weight it like this, it will come 50 gram. If it weight like this, it will come 50 gram. So there is no dependence in direction regarding the case of weight also. So mass also we can say it is also a scalar quantity. Next, force. The force we are applying, scalar or vector. For example, imagine a door. There is a door here. Just imagine that. I pushed it. So somebody told me that, you told me that apply 5 Newton of force to open that door. Just 5 Newton. Understand? The door is like this. And it opens like this. I am applying 5 Newton's power to that door. Will it open? Maybe it will open. If I am coming back from outside, again I am applying 5 Newtons of power. Will it open? Maybe not. Why? Because in that case, we need to apply this force in a particular direction. Understand? If it is door is this, if I push it here, it will open. Understand? If it is a two-way door, I am coming from this side, I push it here, it will open. But if I am pushing from this side, will it open? No. When I am pushing from this side, the door will open? No. Understand? So there is a direction there. Direction is involved in force. So if I want to open this door, 2 methods are there. I must apply force from this direction. Okay, the door is opened. Otherwise, I must apply the force from this direction. So, involvement of direction is there regarding force. Understand? For example, I want to lift this pen. I am lifting it. I want to apply force upside, isn't it? Upside. If I am using that same force down, can I lift that pen? No. Understand? So, this direction is involved in the case of force. So, we can say that force is a vector quantity V. Understand? Whenever we are writing these vector quantities, we must mention it. It is positive or negative. Vector quantity is dependent on direction. Okay? If you are going to the left part of the number line, we can say this positive. And if the vector quantity is going to the right part, we can say it is negative. You know what is number line? 0, 1, 2, 3, 4 to the left, and from 0, minus 1, minus 2, minus 3, minus 4 to the right. Understood? What is scalar and what is vector? In the case of weight, weight is scalar or vector? Tell me. Anything is depending upon direction here? Yes, the gravitational pull is pulling it downside, isn't it? Then only we can say it is weight. So that particular direction is involved, so it is what? A vector quantity. Next one, acceleration. Acceleration of what? Acceleration means the gaining up of speed. Isn't it? If you want to go to market, we need to accelerate in that direction. Am I right or not? Okay, that much effort we want to put in this particular direction. If I am accelerating through this direction, can we go to market? No. So direction is involved in there. So it is also what? It is also a vector quantity. So the next one is displacement. So there is a lots of confused regarding this displacement and the distance. Okay, 2 words, simple words in physics, but lots of doubts are merging due to these two words, distance and displacement. Okay, once again we will go with the motion. Change in position of a body with time is called as what? It is called as motion. Understand? But here one more thing you want to add, my dear kids, that is what? That is the position. Okay, that is position. Position also you must add in the definition of the motion. Understood? Because from here to there, that is also you want to know. From one position to another. Otherwise, it will be very difficult for you to study this displacement. And regarding this part, there is a lots of numericals also is there. Lots of numericals are there. Anyway, it is very simple numericals. Just addition, multiplication. That's it. You must know the terms and all. So while I am going with this class, you must listen carefully. I need a paper for that. 1 second. So for that, anyway, this thing I am going to remove. So you understand? Some of the examples for scalar quantities are length, speed, temperature and mass. Means wherever we measure these things, it is not depending upon this direction. Understand? Vector quantities will contain both. Understood? It will contain both direction and magnitude. But scalar quantity only contains what? Magnitude. There is no direction in scalar quantity. For example, length, speed, temperature, mass. If we measure the length of a particular thing, it will be same in whatever direction we are measuring. From here to here I am measuring, same. Here to here also, same. The length will be a constant. It will be not change. Speed of a particular thing also will be constant in whatever direction we are measuring it. Temperature will also be same, isn't it? If we check the temperature of the sun from this direction, we will get it. If we come here and again we are checking the temperature, we will get the same temperature. Am I right or not? So that is also not direction depending. So it is a scalar. Mass. The common mass of a particular matter is also a constant. In whatever direction we are checking it, it will be same. So there is no involvement of direction. But in the case of force, weight, acceleration and displacement, direction is involved. Okay, that is the thing we want to study next. Let's see. So distance and displacement, mostly in most of the textbooks. Okay, mostly in most of the textbooks, what diagram they are providing regarding this displacement and the distance, how to teach this, how to study this displacement and distance, it is like a number line or a symbol. Okay, I will tell this thing. Just imagine you are standing here. Okay, you are standing here. Okay, fine. And here is an ice cream shop. Okay, ice cream shop is here. Ice creams. Okay, ice cream shop is here. So the length is 20 meters. 20 meters from here to here, it is 20 meters. And here one more shop is there. What shop you want? Okay, bus stop. Here is the bus stop. Okay, whatever thing. This is the bus stop and this is the ice cream shop and you are standing here. So from here to ice cream shop there is 20 meters. The total length is 20 meters. And from bus stop to ice cream shop only 10 meters. Alright. So after the school, anyway your teachers and all already told you that from school directly go to home. But you are very good kids, you won't go directly to home. Understand? You have some pocket money in your hand and even though this is a corona situation, what you will do? You will go to buy ice creams. Am I right or not? I know you are very good students, you won't do that. This is some other students, okay? Some other students who are very naughty students, okay? What they are doing? They are going to buy the ice cream. But what is this ice cream doing here in physics? Let us see. So what is his name? We can call him Tell whatever good name. That's Ramu, Raju, and all its old names. Some new. Huh. Or we can call him A. Quite good names, isn't it? Mr. A, or we can call him Alan. A-L-A-N. Alan, now he is in his school. This is the position of him now. Here it is mentioned as 0. Understand? So, Ramu went to the ice cream shop, bought the ice cream, and he came back to the bus stop. That is the question. How many distance did Ramu travel? How many distance? Okay. First, how many distance? 20. From school to ice cream shop is 20 meters. Then again he is traveling 10 more meters back to the bus stop. So total how many meters he traveled? He traveled 30 meters. Am I right or not? So this is the total distance traveled by Ram. Understood? So it is not regarding any direction, isn't it? From here he changed the direction. Anything changed? No. Distance didn't change. 20 meter plus 10, 30 meters. Understand? So there is no direction depending here. So we can say this distance is also a scalar. But one more thing is there. Displacement. Displacement, actually what is displacement? We can say that it is the shortest distance between 2 points, but another good example is it is the net distance. Net distance means you have to calculate the net distance. How we will calculate the net distance? This is the starting point. This is the finishing point. Okay. Starting point is the school. There the distance is 0. Finishing point, there the distance is 10. From here to here, what's the distance? 10. Any doubt? See, from Damu is standing here. First he went to ice cream, and after that ice cream parlor, and after that he went back to the bus stop. So here to here 10 meter means here to here also is 10. So how we can calculate this displacement? It's a simple equation. Final position minus starting position or initial position, we can say initial IP. Understand? Initial position means the school. Here it is 0. Understand? So FP minus IP will give us what? 10 minus 0 will give 10 meter. Understand what is the displacement there? Otherwise another equation is there. First he traveled 20. Just see this. First he traveled 20 plus then he is traveling 10. But in which direction it is going? It is going in the right direction. Regarding vector quantities, whenever you are doing calculation, if it is in the right direction, you must put a minus sign. So 10 is minus. Minus into plus will give minus. 20 minus 10 will give 10 meter. Am I right or not? Both equations are same. It's a very simple thing. Am I right or not? This equation is also fine. Final position minus initial position is the displacement. One more picture I will draw so you will be able to understand it very easily. This is only for your reference. Okay, only for your reference. Daily, each and every classes we will revise about this displacement. Otherwise, you will forget about the displacement and all. So here, again, Ramu is standing here. Who is standing here? Alan is standing here. Okay, fine. Alan. And here is what? Here is his school. With me. School is here. Big school. Wow. Great. Is a school like this. Okay, just imagine this school. SCHOOL. Anyway, let's give a name of a girl. Okay, give her Elsa. She is Elsa. And this is her school. and her school is 10 kilometers, not 10 kilometers, 2 kilometers. 2 kilometers away from her home. Home is her starting position, isn't it? Home is her starting position or initial position, IP. So she wants to reach the school. So normally what will be the final position? FP is school. Simply we can find out the displacement here with the equation. Final position minus initial position, we will get 2 kilometers as the displacement. There is no change in that. But you know, Elsa is not a very innocent girl. First she went where? Here is the ground, playground. Understand? Playground. Half kilometers, 0.5 kilometers. First she went to the playground. After that she went to beauty parlor. Beauty parlor. Beauty parlor is 1 kilometer from the playground. From the playground. Next, again she went to an ice cream parlor. Ice cream parlor is also 1 kilometer from beauty parlor. 1 kilometer. Then she went to school. Again, half kilometers. Understood? So, tell me, how much distance totally Elsa travelled? From this diagram, you must tell me that what is distance equal to and displacement equal to what? Tell me fast. Okay, displacement anyway you know. Final position minus initial position will give 2 kilometers minus 0 kilometers will give you 2 kilometers. Am I right or not? Isn't it? So displacement is measured in a particular direction. Understand? If you are measuring it in this direction, you won't get the displacement. That's why it is a vector quantity. Here, just tell me how many kilometers totally Elsa travelled. First she is going to the playing ground, then she went to beauty parlor, then she went to an ice cream parlor. After that she is reaching the school. So total how many? 0.5 plus 1, 1.5 plus 1, 2.5 plus 5.5 gives 3 kilometers. Understood? From this we can say, conclude one more thing. Distance will be always greater than displacement. Understood? That's a very important equation, not an equation, we cannot say that. Distance is always greater than displacement. In one condition, distance will be equal to displacement. What is the condition? If Elsa was a good girl, she will directly go to school. In that case, okay, this day anyway she was caught by the principal. Principal asked her, why you are late? The next day you must come directly to school, otherwise he will beat her. So the next day what Elsa did? She directly went to school. So in this case, how much is the distance travelled by Elsa? 2 kilometers, directly, straight. She didn't went here and there. She became a good girl. Isn't it? So here Elsa travelled same kilometer, 2 kilometers. That's the displacement, that's the distance. Sometimes distance will be equal to displacement. Understand? Distance is greater than or equal to displacement. It will not be, distance will not be less than displacement. Understand? Every time distance will be more or equal to displacement. Distance cannot be less than this displacement. So at the end of the story, what we can say that? We can say that Elsa became a good girl. Understood? So displacement and distance is same in the case of Elsa. Understood? So the next class we will again one more time discuss about it. After that there is different types of motion we will go. I hope some of the things you understand. It's a very difficult part. It's not that much easy. It's a very advanced or old classical physics. So it will be very difficult for you to understand. So this starting time give more concentration on this physics part. Biology and chemistry, that's much difficult. It's not that. So that's it. Next day we will continue the same chapter. Till then, Visit Drive signing off from this part of the world. My dear kids, stay at home, stay safe. Okay, stay at home, stay safe. And what all works I am giving, just try to do it. And the next day I will give some question answers regarding this. Okay, next day. Or evening I will give question answers regarding this. What you want to do? You want to fight it out during with that equation. Some equations also I will give. A bit more portion is there. After covering that, we can have the numericals and all. Numericals, once you got the concept, it is very interesting to solve that. Okay. So my dear kids, till then, goodbye, stay safe and Jai Hind.